Welcome, Autodesk Inventor users. So this is part 2 of a multi-part series dedicated to creating sketches. And what we want to focus on today is how to implement or enforce constraints. So let's go to New, Standard IPT, Part, and hit Create. Come up to Sketch, Start 2D Sketch, and then pick one of our sketch planes. Okay, so in our first video we created on sketching, we just discussed how to create things like lines, circles, arcs, rectangles, and how to dimension them. Taking it a step further, it's very good practice to enforce constraints or establish constraints. What are constraints? Why do we need constraints? Well, in many practical applications, you have parts that have planes of symmetry. You might have parts that have concentric circles. You might have line segments that are supposed to be either parallel or perhaps perpendicular to each other. And you might be even creating constraints and not even realizing it. So for example, if I create a rectangle, notice that when this feature is generated, you see these little images pop up, and these are known as glyphs. So for example, this glyph over here on the left, next to this vertical line, is telling me that this line segment is parallel to this line segment. Likewise, we have this line segment up here being parallel to this line segment down here, and so on and so forth. This is perpendicular, so it's telling me that the angle between this top line segment and this vertical line segment are 90 degrees. If we want to verify that, we can simply dimension, and you can see that Autodesk is telling me that we have 90 degrees there between those two segments. Now, notice that if we change the dimensions of this rectangle, right? I want to have a rectangle. I want the angles to be 90 degrees, and I want the various sides to be parallel. And if I change my dimensions, let's say I want to make this now 1/2 inch, the overall size of the rectangle changed, but all of my constraints were enforced. So I still maintain 90-degree angles where I want them and the parallel lines where I want them. If those constraints weren't there and I made the changes to the dimensions, my rectangle might become some other shape, might become something else that I just don't want at all. Okay. So let's step through as many of these as we can to understand how they work. So for example, the first one here is a coincident constraint. So if I draw two lines, notice that they are not touching one another. But if I use the coincident constraint and I pick this line and this point here, it now joins them. And anytime you see like this yellow box come up, that means that the endpoints of these two line segments are now joined. We can look at the next one on the list here is the collinear constraint. So if I pick, say, two lines, and now collinear means that these two segments are going to be sort of running along the same linear path, or they share the same axis, if you will. So if I select this segment and this segment, they have different lengths, but you can clearly see they're basically running along the same line, hence the name collinear. The next one on the list would be looking at concentric circles. So if I have a circle here and another circle here, and notice they have different diameters, but I want them to be concentric, meaning I want the center points to be shared. I click on my constraint, and then click on the two segments. So in this case, I'm clicking on this circle on the left and then the circle on the right. And you can see that the circles are now concentric. Now let me undo that. I'm going to hit Control Z. That undoes that last command. Let's look at the lock feature first. So let's say I want this circle to stay put, and I only want the left circle to move. So if I were to hit the lock or fix feature, and then this circle on the right, and now pick the concentric command, and then pick the circle on the left and the circle on the right, it should force the big circle to be concentric with the little circle, but the big circle is going to move to the right, which it did. And the reason it did that, again, was because I fixed or locked the position in space of the small circle. The next one on the list is parallel lines. So if we have a couple of line segments that are clearly sort of skew to one another, they're not parallel, I can click on my parallel constraint, left click on the first segment, left click on the second segment, and notice that the two lines are parallel. And again, if I were to grab one of the endpoints of the lines and make it bigger, notice that it still enforces the constraint between them, which is that they're parallel to one another. So I guess you could say the inverse constraint relationship now would be looking at two line segments not being parallel, but I want them to be perpendicular. So if I take two segments, and let's have these segments touch. So you can clearly see that if I were to measure the angle between them, it's about at 65.8 degrees. I want that to be 90 degrees. I click on my perpendicularity constraint and click on the two segments, and you can see I have a nice right angle between them. Okay, the next one to consider for right now would be parallel and vertical constraints. But parallel and vertical to what? Well, if we look at our global coordinate system down here on the lower left corner, notice that our x-axis, it sort of represents the horizon. It represents lines or an axis running to the left or right on my screen. So for example, if I draw this line segment here, notice that it's not parallel to my x-axis. If I want to make it parallel to the horizon, I click on my parallel constraint and then the line segment, and you can see that this new glyph is generated. And again, if I change the dimension of the line, let's make this 1.5 inches. Notice that it made the line a lot longer, but the line is still parallel to my x-axis. Likewise, it's the same situation for vertical constraints, in that if I want this line segment to be parallel to my global y-axis, I simply use the parallel constraint, as you can see here, and it makes it now running in the same orientation as my global y-axis here. The two axes, or this line segment and my global y-axis, are now parallel. Okay, let's look at creating tangent conditions between two entities. So if I have a circle and then I'm going to draw this line segment over here, but I want to make it so that this line segment is tangent to the circle. Again, I select my circle and my line, and you can see it brought the circle down to where now it's tangent to this line. And again, if I make the line segment longer, right, it always maintains this point of tangency down here. Okay, the final one to discuss for right now is one that's actually very, very useful. It's known as the symmetric constraint. So I'm just going to pan down and start over again. Okay, so let's look at this with a practical example. Let's create a rectangle. And what I'm going to do now is create a line segment to represent my axis of symmetry. So notice that when I bring my cursor down to this top line, you see that the circle there is yellow. But if I move my mouse to the right, eventually it will change to a green color, which is telling me I'm at the midpoint of this line segment. And if I left click and move my mouse down, I'll snap to the bottom line segment, the midpoint of the bottom line segment. Now what I'm going to do is just create a couple of circles to show how this works. I'm going to move this circle down here. Okay. Now what I want in this case is this basically maybe a rectangular plate with these two holes being the same diameter and essentially being located at the same, sharing the same location relative to this vertical line segment here. Well, how do I do that? There's a couple of different ways. I could simply get the dimensions I want and dimension this circle, say relative to these two lines, or maybe relative to this line and this bottom line, whatever you want to do, and repeat that on the right side, which is fine. You can certainly do that. That's a very intuitive way to setting this up. You could also use the symmetric constraint, which might be a lot faster. So if I click on that and then click on the left circle, click on the right circle, and then click on the middle line, because that is representing my line or plane of symmetry, my axis of symmetry, you can see it changed the diameter of the circle and it put them at the same position relative to my vertical line here. And this is very beneficial because let's say I go and I want to change the dimension, this vertical dimension, from 0.75 to 0.5 inches. You can see that it maintained the same symmetry condition. Or if I want to make this 1 inch, notice that again, everything is still symmetric about this vertical line. Likewise, if I were to change this bottom dimension, let's make this an even 1.5 inches, you can see it still maintains symmetry about this vertical line. So in a nutshell, this basically captures a lot of what I wanted to discuss in this video about establishing basic constraints, and I hope you found it instructive and enlightening with respect to understanding why constraints are important, how to implement them, and take advantage of them in your sketches. So thank you so much for your time and attention today.